Hello, Honors Pre-Calculus. Today we are starting section 6.5. We're only doing part of it. And the part that we're going to start talking about is the complex plane. Just as real numbers can be represented by points on the real number line, you can represent a complex number, z, which equals, there you go, a plus bi, as the point a comma b in a coordinate plane, which we're going to call the complex plane. The horizontal axis is called the real axis, and the vertical axis is called the imaginary axis, just like this. So where we were to graph like the ordered pair 3, 1, we can now graph 3 plus I. 3 would be on the real, I would be on the imaginary. Or -2, -1, -2 would be the real, -1 would be the imaginary. The absolute value of the complex number, a plus bi, is defined as the distance between the origin and the point. So that would be the absolute value between the origin and the point. So here is a formula for finding the absolute value. You'll notice that it is Pythagorean theorem, or the distance formula. And then if the complex number is a real number, so meaning that we don't have the bi at all, the definition would be the exact same for the absolute value. If it was a real number, I'm going to go back up to the real number line here. Like just the absolute value for -2 would just be but 2 on the real number line. So find the absolute value of a complex number. We've got, and we're going to plot it. Z equals -2 plus 5i. So I'm going to plot -2 and then a 5 for the imaginary axis. Okay, and then we're going to find its absolute value. And oops, 25. So we get square root of 29 as the absolute value. All right, so this next section, we are learning about the trigonometric form. And it says in section 2.4, which is why we just did 2.4, you learned how to add, subtract, multiply, divide. To work effectively with powers and roots of complex numbers, we have to be able to write these in trigonometric form. Okay, so the a value we can write as r cosine theta, and the b value we write as r sine theta. R is the absolute value, so r equals square root a squared plus b squared. And because of that, this is how we would write the trigonometric form. We've got our a plus bi, so our a value is r cosine theta, and our bi would be r sine theta times I. And here's the box that talks about, in this box, it also says that to remind you that tangent of theta is b divided by a, and then the number r is the modulus. R is the modulus of z. And theta is called an argument of z, where z is the imaginary number, or the complex number, I should say. This paragraph talks about the trigonometric form of a complex number is also called the polar form, which we are going to study very soon. It's pretty cool stuff. And then because there are infinitely many choices, this complex number is not unique. So normally we restrict the interval from 0 to 2 pi. And then it says, although on occasion it's convenient to use theta is less than 0. All right, write this complex number in trigonometric form. So this would be a good time for you to pause it. See if you can do it on your own. And then, play it to see how I did it. Okay, so we're going to talk about the absolute value of z. And the absolute value of z is the formula where we're going to take the a value and then we're going to add that to the b value. Oops, negative. This will be 4 plus, it'll be 4 times 3, 12. Just square root of 16, which is 4. So there's our absolute value. And then we need to find theta. And to find theta, we're going to use tangent. So we're going to do b over a, which is negative 2 square root 3 over negative 2, just square root 3. And then before I can answer that, I need to know where negative 2, negative square root 3 is. So negative 2, negative 2 square root 3-ish. I don't know how far that's going to put me, but it's in the third quadrant. So we're going to find a theta in the third quadrant that gives us tangent of square root 3. This is the one of the ones that we should know. I do not know why the book would choose radians versus degrees. I will have to find out that information after I'm done recording this video, but they chose radians. So they chose to find the theta. It's a 60 degree. So in this quadrant, it would be 4 pi over 3. So there's our theta. So now our trigonometric form, which is r cosine theta plus I sine theta. Oops. We're going to plug in the information that we know. We know our r is 4. And then we have cosine 4 pi over 3 plus I sine 4 pi over 3. So that would be the trigonometric form. Now writing a complex number in standard form. So this is in the trigonometric form, and we're going to go backwards. So let's see. We know that cosine of negative pi over 3 is it's a 60 in this quadrant. So that's going to be negative a half. Nope, not negative. That's going to be a half. And then plus, and then we have our I, and then we have to do sine at the same location. That's going to be negative square root 3 over 2. I hope I have an extra parenthesis. And then I'm going to put the square root of 8 outside. So let's see. Square root of 8 is 2 square root 2. here. I'll go ahead and distribute that. So we'll have 2 square root 2 over 2 minus 2 square root 3, oops, 2 square root 6 over 2, and then I, and then reduce. And then we have the standard form of the complex number. All right, multiplication and division of complex numbers. So if we've got Z1, so we've got one complex number here, and Z2, another complex number right here. We're going to multiply those together. So they're showing right here, Z1 times Z2. To multiply those together, we're going to multiply the stuff that's in the same location together. So we'll multiply our R1 and our R2 together first. And then they just put the parentheses next to each other. And then from here, we're going to use the FOIL method to distribute. And we get this step. Now, the next thing that they do is notice that this is cosine theta 1, cosine theta 2, subtract sine theta 1, sine theta 2. Well, we've learned that in chapter 5 to be the sum of cosine, the sum of cosine. So they took that down to cosine theta 1 plus theta 2. And if you look over here, oh, I'm sorry, I forgot to say, they foiled it, and then they put together the two real pieces, and then they put together the two imaginary pieces so that they could factor out the imaginary number. I had to like think through that when I was going over these notes earlier. All right, where was I at? Oh yeah, and then so for this one here, sine theta cosine theta plus cosine theta sine theta, that is the sum of the sines formula, so that we rewrote that. I didn't understand. My phone is talking to me. She heard me talking. Okay. So now all of that's just kind of summarized in the product and quotient formulas. So both of these come from the same work above. They didn't show how to get the quotient, but that's how you get the product. So here's the two formulas we need to know. And then they have note. The rule says to multiply the two complex numbers, you multiply the moduli, which are those R values, and add the arguments, which are the thetas. But when you're dividing two complex numbers, you divide the moduli and subtract the arguments. And I would compare that to if you were doing exponents, if I did like x squared multiplied by x to the 6, we would add. Where if I did x squared divided by x to the 6, we would subtract. It's kind of like those same rules, only it's not exponents. So multiplying complex numbers. So here's two complex numbers. Let's multiply them together and see what we get. So we are going to multiply the moduli, the 2 and the 8, 16. And then we are going to add the, sorry, I have to flip back for my formula. We have to add the thetas. So we're going to have the arguments. There, that's the word I was thinking of. Cosine of two pi over 3 plus 11 pi over 6. Okay, and then plus I think I didn't have an extra parenthesis. Here we go. And then we've got our I value. And then we'll have sine of 2 pi over 3 plus 11 pi over 6. Okay, so we got to add these together. 2, 2. So cosine, that's going to be 5 pi over 2. After I add those together, that would actually give me 15 pi over 6, but it's 5 pi over 2. Oh, I did it again. Plus I, and so that'll be the same number, sine and then cosine 5 pi over 2 and sine 5 pi over 2. So 1, 2, 3, 4. That's the exact same location as pi over 2. So if you wanted to think about it that way, you could. Or you can just use 5 pi over 2. Either of those is going to be the same. So we went through the entire question, and the complex number is just 16i. There's no need to write 0 plus 16i unless they specifically say it must be in the form of a plus bi. Usually we don't include zeros, so we would just write 16i. You can check this result by first converting the complex numbers to the algebraic forms of -1 plus 3i and 4 square root 3 plus 4i, or minus 4i, sorry, into the algebraic. And then you can multiply those algebraically. So that's going back to the original Z1 and Z2 up here by finding what's the cosine of 2 pi over 3, what's the sine of 2 pi over 3, distributing the 2, doing the same thing for the other one, and then, excuse me, you would get -1 plus square root 3i. And then you can multiply that by 4 square root 3 minus 4i. And it should work the exact same. You should get the exact same answer of 16i. So there you go. Okay, dividing complex numbers. Again, I'm going to use the formula that was in that previous box, which says, I'm so sorry, I'm just so coffee today. So I'm looking back at the box. You guys have it in your notes, but it says to do, I'll just rewrite the formula right here. R1 over R2, and then we have cosine. So this is what I was saying before. When we divide it, you're going to divide the moduli, and then we're going to subtract the angles. So, or the arguments. Cosine, we're going to do theta 1, which is 300, minus theta 2, which is 75, plus I sine 300 minus 75 degrees. All right, so, oh shoot, I was trying to write the formula and then I just got carried away. Oh gosh. This was supposed to be theta. Theta 1 minus theta 2. 1, theta 2. Now I'm going to plug it in. So I'll do 24 over 8 cosine 300 minus 75 plus I sine 300 minus 75. So then I've got cosine of 225 plus I sine 225. So 225 is in this quadrant. It's a 45-degree reference angle. So that would be negative square root 2 over 2 plus I times negative square root 2 over 2. Oop, I wrote too big. So multiply that out. I'm going to get negative 3 square root 2 over 2 minus 3. I'll put my I right here. Square root 2 over 2. Maybe I'll put it back where normally. 3 square root of 2 over 2 I. Write it like that. And then I think that's it. Yep. Okay, last part that we're going to do is powers. Powers of complex numbers. So if we were to raise each complex number by a power, we could do that using multiplication. So here z squared would be like z1 or z times z, which we'll treat as the multiplication formula. And so we get this answer right here. So z to the third, we will take the z to the second answer and multiply it by one more z. So we get the third power. And then just following that pattern, we can find any power. So this was named for the French mathematician. And you know what? I should have looked up how to say the guy's name because I didn't think about looking it up before I got to look it up before I made a video. I don't speak French either, so I'm not going to be able to figure it out. Let's see. Pronunciation of all right, so this first guy, it's like a minute-long video. I just want to know how to say the guy's name. Demoivre. Oh, okay. Demoivre. I apologize. If you guys speak French and I'm like butchering it, I'm so sorry. Demoivre's theorem that says if we want to raise any complex number to a power, that we will put that power on the R, and then we will put it as the number of angles in the theta spot. We'll make it a multi-angle. So here we're going to find powers of the complex number. This one is the 12th power. So let's first convert this to trigonometric form, where a is -1, b is square root 3. So we're going to do our modulus. So I get 2. And then our theta, our argument, we're going to do tangent of square root 3 over, oh, I didn't do that right, tangent arctan. We'll do tangent inverse because we're undoing it. So that would be in which quadrant? -1, square root 3, it's somewhere up in this quadrant. So this is going to be a 60-degree reference angle, 2 pi over 3. So we've got our theta. So now our z is going to be 2 times cosine 2 pi over 3 plus I sine 2 pi over 3. All right, so now we can use oh no, I forgot how to say his name. Dimwar, oh no, I can't do it. Dimwar. Oh my gosh, please don't laugh at me. We're going to use his theorem that says if we want to do z to the 12th, if we want to do 2 cosine 2 pi over 3 plus I sine 2 pi over 3 to the 12th, then we will do 2 to the 12th multiplied by cosine 12 times 2 pi over 3 plus I sine 12 times 2 pi over 3. All right, so I'm going to type this into my calculator because I don't know 2 to the 12th, unfortunately. 4096. And then let's see, multiply those together. That'll give me a 4. So cosine 8 pi plus I sine 8 pi. So 8 pi is the same thing, 1, 2, 3, 4. 8 pi is the same thing as just 2 pi, or it's the same thing as 0. Same location. So I'll just think about this being 0, cosine of 0 plus I sine at 0. (4096) multiplied by 1 plus 0i. So 4096. That is -1 plus square root 3i to the 12th. It's 4096. I wonder if the 12th root of 4096 is equal to -1 plus square root 3 I. Okay, so you have your first half of your assignment, and that will be due the day after we take our next quiz. Have a great day. Bye.